Okay, this video is to give you an idea of what you're getting into with experiment 4, second order systems. In this experiment, you will have a signal generator, an oscilloscope, components to make an RCL circuit, LoggerPro DAC system, and computer interface for LoggerPro. First off, as we focus in on the signal generator, you'll see that it's set to output square waves. As you can see, as I focus in on this portion where it says function, you set it to square wave by pressing the function button until you get to square wave. Make sure it's set to 20 volt peak to peak, and make sure that it's set to 10 hertz. So right now it should be outputting a 10 hertz signal. That signal is going to what you will have, or you will construct this, but this has already been put together, the RCL circuit, where this smaller cylindrical piece is the inductor. The cylindrical with the purple on it is the capacitor, variable resistor, and some connectors in order for you to attach your signal generator, function generator, which will output a step function in the form of a square wave to the RCL circuit. And then you have your oscilloscope connected to the output to visualize the response of the second order system, which is the RCL circuit. And at the same time, the LoggerPro DAC system is connected to the same terminals as the oscilloscope. Just to focus in on the oscilloscope, this is what you should be seeing. If you press auto set, you can try to hone in on this, but as you can see, I have my time-based scale here, where each square is 1 millisecond, and then I have here as my scale for the y-axis is 5 volts. So you can see here that the underdamped response, where the square wave comes, inputs a signal, steps up to 10 volts, and then the system responds and dampens out. And as I turn the variable resistor here, you can see that that has an effect on the dampening. I can turn this to a critically damped system and then overdamped if I want to go that far, but we're not going that far in this experiment. So you have two responses you need to look at: underdamped and critically damped. And you can see the response. Again, you're going to have to play with the oscilloscope in order to be able to focus in on this, because this time scale is very small. You should be able to calculate the natural frequency of the system, which should be reflected by this wave. This signal that you're seeing here is the response of the RCL circuit, and that natural frequency is a function of the capacitance and the inductance. So the equation in your experiment handout should be able to give you what that natural frequency is. As a result, in order to be able to record that response, you're going to need to take LoggerPro and set an extremely high sample rate. Now, I think in your notes I say set the duration to a very small duration. Let's say 0.005 seconds, and to a very, very high sample rate. I am going to focus away from the sample rate, since I went ahead and asked you guys to figure out what that sample rate is on your own as a function of the natural frequency of the system. But I do want to show you what triggering is. You go here to triggering. What triggering does is that this option allows you to set a trigger point for LoggerPro to start recording after it senses that the signal is going to surpass a certain threshold voltage. So for example, if I set this to 5 volts, I should be able to start recording this starting at 5 volts. So when it sees that step input of the square wave coming in, it's a 10 volt peak to peak. When it hits past 5 volts, it'll start recording data. And then we talked about collecting 5 samples before the trigger point. So at this point, my inputs are done. I'm going to go ahead, press collect, and I should see LoggerPro record my response. Again, this surpassed 5 volts. So what it's going to do is it's going to collect the data from 5 volts on, and then also collect 5 points prior to that. So there's my underdamped response, and I can do the same thing for my critically damped response. You output the data as a text file, and you can do all of your analyses in Excel. That is about it. The only things I want to mention is if you're not seeing your signal output in your oscilloscope, you can try rearranging on the RCL circuit where you have your negative and positive inputs and from the signal generator, and also your outputs for the oscilloscope and Logger Pro. And I can also help you with that if you're having issues. So that's about it. The rest of it is all just analyzing the data in the form of Excel. There should be some clear instruction in your experiment handout for that, but I can also be here to give you some guidance in that as well in person. Okay, so that concludes the instructional video for experiment number 4, second order systems.